Alright, so good morning. Today I will pick up a topic which is causing a lot of confusion in students, okay? Those who are preparing for AP Physics, NEET, JEE, whether you're in India, Bangladesh, Philippines, Taiwan, you're in United States. This topic is very important. Listen to this very carefully, okay? Now, the confusion is whether in a given situation or a numerical, work has been done or not. This is a confusion students have, and I'm going to clear this confusion in a minute, okay? So listen to this very carefully. So let me draw the first situation, okay? Now the situation is you have a body which is connected to a string. So what I'm drawing now is a string, and this is your body, okay? So this is a fixed point. So this is a fixed point, right? And you're, with the help of something, you're holding this. This is at a height, and this is where the ground is existing. So this is your ground, okay? Earth. So this is your ground. Now what you do is, this point is fixed. You leave this body freely, okay? This body then comes like this, okay? This body comes like this, and it reaches this point, right? And then of course it continues its journey like this, right? But that is not what we're discussing. We're discussing the confusion you have. If you notice, the height of the body above the ground, okay, above the ground, for example, is mgh, right? This is the height. So if I were to calculate the potential energy of this body at this point, it is mgh, and I left it freely to let it fall, right? It came here and it acquired a new height, which is h2, okay? Let the velocity of body here be u, let the mass of the body be m, right? What is the energy here? The energy here is mgh2 plus half m u square. I think most of you understand this without any confusion, right? That this is a state case of law of conservation of energy. But there are certain situations in a similar question where you cannot apply the law of conservation of energy. And let me tell you why. And this is a source of confusion a lot of students have. And this concept will help you solve those problems. So let's take a similar situation, okay? This is the situation number A, which we have discussed, okay? Now let me do one thing. Let me just draw a similar diagram here, okay? So let's draw the similar diagram here, and let's say the body is held like this, and this is the fixed point. This is the mass m. This is the ground. Okay, this is the ground. And now what you do, instead of leaving it freely, don't allow it to come freely. Hold it from here, okay? And allow it to come with the help of your hand at a constant speed, okay? Control the speed. Now what you're doing is different. This is free fall, right? So A was a free fall, and this was your massless string, okay? This is not the case of free fall. What you're doing is you're holding it with the hand, and now you're bringing it down in a controlled manner, gradually, okay? And therefore it does come to the same point, right? It will come to the same height as this, and it does reach the same height, right? So it reaches the same height. And now what you're doing is, if you notice this situation, you know the velocity throughout this motion is variable, right? So you have a variable velocity, right? And it's under the influence of gravity, g. So you can find the velocity using v square is equal to u square plus 2as, right? But in this case, the motion has been controlled. The velocity is not variable, okay? What you're doing is you're controlling it because you're holding this throughout the journey to the bottommost point. So the velocity here is constant, okay? The velocity here is constant velocity using your hand, right? So you are using your hand. Can we apply the same equation we applied to this situation or not? That's the question. Can we apply the law of conservation of energy? Can we apply law of conservation of energy to this situation where the body is being controlled like this, okay? No, you cannot apply. And this is the confusion students have. So in some questions, you will find that it is given that while the body is coming down, right? And this is your string again. This is your massless string. This is your massless string. The body is not going to come with with a variable speed, but a control mechanism has been provided, and therefore what we say is that you're doing an external work. So situation 2, okay, or B, you're doing external work. External work has been done. And what is that external work? That external work is the hand control you provided, the hand control that was provided, okay? So that particular control mechanism, right, is the work. So you're bringing it down slowly at like this, right, with a controlled velocity. And this is the difference between the two situations. So you will come across many questions in physics in multiple chapters where you will realize in one situation you have no external work. So here the external work, W external, okay, is equal to 0. But in this case, you have external work, and therefore, please do not apply this equation that, you have a potential energy plus kinetic energy, and you have a potential energy here. You cannot write potential energy 1. Potential energy 1 is not equal to potential energy 2 and kinetic energy at this point, right? So, and the kinetic energy at the bottom point. I hope this is clear. So whenever you read a numerical of mechanics, be very clear that the velocity is being controlled by some mechanism at a constant velocity, right? Whereas your common sense tells you, it is coming down, so you can apply law of conservation of energy and find out the velocity maybe at this point or any unknown variable. A lot of questions on momentum, on the law of conservation of energy. Generally, if you notice, the simple ones are like this, but the ones which are complicated and tricky and are very common in AP physics or SAT physics, or for that matter NEET, JEE, or whichever part of the globe you are based on this understanding. Whether you really understand that there is an external work and therefore no law of conservation of energy is possible. So I hope you like this video. If you did, please subscribe to this channel. You will see some outstanding mechanics, electrostatics. I have playlists for almost all the chapters in physics you can think of for class 11th and 12th. And I will be coming out with more videos where you will see me pretty often now. All right. So thank you very much for your time and look forward to meet you soon. Thanks.